Hello and welcome back. This is Barrett from the C4 Cyber Club here at Cypress College. And in this lab video today, we're going to cover the CySA Plus lab series, extracting data from a compromised machine. So this is essentially all about we're going to create a remote access Trojan, or a RAT as they're commonly called. And this one's going to be relatively malicious. All it's going to include is a reverse shell payload that will beacon back to our Kali machine, or in real world scenario, this would beacon back to like a command and control server, for example, that's what a lot of malware does to create botnets and things like that. So we'll go through that process. We'll set up our command and control server on the Kali machine, and then we will deploy and execute. Essentially, we'll send that to the Win client machine through the FTP protocol. So we'll go over that. And then finally, we'll see how we can control this Win client after it's executed the Trojan using Meterpreter through Metasploit. So we'll have a lot of access there. So it goes without saying, especially this type of lab, this is for educational purposes only. Do not do this at home. Remember, these net labs are sandboxed environments, so we're able to create these things and simulate these activities in a safe manner. But this is the best way to really see what's happening behind the scenes, is to really get hands-on and actually create these Trojans ourselves. So let's go ahead and hop into it. We'll be using the Kali machine and the Win client. So let's go ahead and get logged into the Win client machine first. We'll want to send a Control-Alt-Delete. Password 123. In this first part, essentially what we need to do is launch the FTP server. So we're going to use the server manager here. Let's go ahead and open the Windows menu here. Now on Server Manager, we want to right click, go down to More, and then Run as Administrator, because we're going to make some changes. Remember, if you ever forget these credentials, they are in the lab right here. Okay, so Server Manager is loading, and now we need to go to Tools and come down to Internet Information Services Manager, IIS. And we're going to go down to Stewart here. And then I believe it's under Sites. Yes, under Sites and under Win Client FTP. We're going to go ahead and right click on that, choose Manage FTP Site, and then just start it. And that is it. We can close out of Windows Server Manager. And then from here, let's go ahead and move over to Kali. Okay, so I've already got mine logged in. Remember, the password is TOOR, username is root. Now we're going to be using msfvenom to generate our Trojan backdoor. And we're going to be placing this payload within a common tool that's used on Windows machines, which is called PuTTY. And this is used for SSH connections, remote management, things like that. So you'll see how you can inject these payloads into everyday applications, which is the very definition of a Trojan horse, right? It's malicious code that's injected in a common application. So first, we could take a look at the payload that we're going to be using and look at the payload options. Okay, so we want the payload options of -P, this specific payload. And this is a Windows format, x64 architecture. And it's going to be launching a Meterpreter shell through reverse TCP, meaning that when the Trojan is launched, that victim machine is actually going to send a shell back to us, to the Kali machine, hence the reverse shell. Okay, so when we press enter, this is essentially just kind of like think of it as like a help file. It shows you all of the potential options within this payload. And if I scroll up to the top, you notice this is where we ran the command. So here are the various options for this payload. It tells you who created it. Essentially, all we need to focus on for this lab, this introductory lab, is the L host and the L port. Okay, because we're going to be changing the L host to our Kali machine, and we are going to change this L port. 4444 is pretty much what Metasploit always sets as default, and this is kind of a more of a red team attacker offensive security tip, but a lot of monitoring tools are going to be looking for this port because it is set by default. So it's generally good practice if you get into pen testing, things like that, to change this port because you don't want it to be easily detectable by monitoring systems. Okay, so this next part of the lab here, this is very useful. It goes over the different options that we're going to be using. So we're going to be setting, telling msfvenom what type of architecture we're using, the platform of the payload, the very specific payload, which is the Windows x64 Meterpreter Reverse TCP, which encoder to use, how many times we would like to encode the payload, the output format. So we're going to be using exe, for example. And then this -x, this serves as a template, and we're going to feed it a currently existing file, in which case is going to be a PuTTY executable. And then finally, --out. This is where we want to save the payload to. Okay, so we need to move into a folder called backdoors. So cd backdoors. If we do ls here, list out the context, we see we have putty-a.exe and putty-at.exe. So this is going to serve as the template, like we were just talking about. And when we come to the lab, we see this long command here. So be mindful when you type this in. Syntax is very important. So I'll go ahead and kind of talk you through as we type this out, because it's important to know, and it's basically what we just went over here, what each of these options means. So msfvenom is the tool, right? So we're running that command. -a x64, we're determining the architecture. So this is a 64-bit architecture. --platform, it is a Windows platform. So remember, we are targeting the Win client machine. -p is to set the payload. So this is the payload we want, the Meterpreter Reverse TCP. The encoder we are using is Zeto Nikuru. Whoa. Wow, my typing was way off there. We're going to iterate through that encoding 3 times, -i3. The format, exe. The template file, the -x is putty-a.exe. And we want to output that to putty trojan.exe. And now finally, the most important part, the L host equals, and now this needs to be the IP address of the Kali machine, because we're going to be, once the one client runs this Trojan, it needs to know where to send back to. So we are at the 192.168.1.3 machine here. And then finally, L port. Remember I said Metasploit usually defaults to 4444, but here we're going to change this to 5000. Okay, so I'm going to go and press enter. It's going to take a moment And this right here is basically telling you what's happening. We have the original executable, and you run that and it runs the program code, right? Well, in this case, we're compromising the original file. So it's going to run the Trojan code first, and it's running the payload that we're entering in, and then it will run the original program code. So from the victim side of things, the program still runs as normal, as instructed, as advertised, right? So they may not know what's happening in the background, but little do they know they've beaconed back to a command and control server, and then we will have access to their machine. Okay, so next thing, the most important part here is we've created the payload, but we need to set our Kali machine up to be listening for anybody who runs that Trojan and is attempting to beacon back, right? So we want to start up, let me go and clear the screen here. We want to start up, and also before we do that, let me ls just real quick. You notice that puttytrojan.exe has been created. So this is our Trojan executable right here. Okay, so we have to start the Metasploit framework database. So msfdb, whoops, start. Okay, starting database. And then we can just go ahead and launch Metasploit. All right, so now within Metasploit, you'll notice that in the lab here, it just says use this exploit, and it's called handler. So this is just a simple way to set your Kali machine up to be a listener on a specific port. So it's not like we're not exploiting any particular vulnerability in the other system. We're assuming that it's going to run that Trojan, let's say likely through maybe like a phishing campaign. Now in this lab, we're just going to download it directly. We're actually going to send it to the Windows machine through FTP. That's not, well, that could be a legitimate way for an attacker if your FTP server allows anonymous logins, for example, and it's not secure, and you could actually upload a file to like a web server, for example. Sometimes that is a way that an attacker could compromise a web server. If they're able to get that Trojan on the server and then access it from the website, then that server is compromised, right? So that is, well, and we'll get to that in a second. I'm kind of getting ahead of myself. But essentially what I'm trying to say is we set up the Kali machine to wait, and it's waiting for that victim to run the Trojan and for the payload to execute. Okay, so we just want to use exploit multi-handler, and we want to set the specific payload that we are waiting for to execute. So we know that we are using Windows x64 interpreter reverse TCP. And now here we also want to set the L host and L port as well. Whoops, I typed that out wrong. There we go. Set L ports 5000. Okay, and now that's all that we need to set here. And now we just go ahead and run that. So you notice that it says started reverse TCP handler on 192.168.1.3 at port 5000. And we have this blinking cursor. That means we are just waiting. Okay, so you want to leave this terminal open. Make sure you don't close that. And we will need to launch a new terminal window now. So we can just go to File, Open Terminal. Okay, so we have that one in the background, just kind of waiting. Now, let's go ahead and cd into backdoors again. Oh, sorry, we are already in there. If I do ls, we see our puttytrojan.exe. So remember, we set up the FTP server on the Win client machine. So we're just going to FTP into that at 192.168.1.5. And that happens on port 21. Now, in this scenario, it's assumed that we know the administrator login and password. A lot of this is kind of just to get the file over there for demonstration purposes. If you like to use your imagination, you could think that we targeted this machine through a phishing scam, for example, and once you've gotten the file over to that system, just imagine, okay, they just downloaded it, they got tricked, and then they opened this file. But this is also a good example, good scenario of using an FTP to transfer files as well. So first thing we want to do is ensure that the file transfers properly without any errors and switch to binary format mode. So just type in binary. And now simply the command here is put, and we are going to put the puttytrojan.exe, but as we upload it to this FTP server, we're going to rename it to putty.exe. So we don't want it to look obviously malicious. On our end, it was maybe good to mark it so that we know for sure. But here, we are just going to upload it to the Windows Win client as putty.exe, which is also what the normal putty executable looks like. So make it look more normal. Okay, we see data transfer is complete. Now, if we come back to the Win client, let's go ahead and open up the File Explorer, go to C drive, FTP. We now have putty.exe here. Okay. So let's go ahead and double click it. We've got a spinning wheel. And interestingly, I noticed this the other time that I ran this lab, it actually doesn't open up putty. So this maybe not the most perfect Trojan. However, for demonstration purposes, if we go back to Kali, I can close out of this terminal where we were FTPing. You notice that since we ran that, Meterpreter session 1 opened. Okay, so we're the Kali IP here connected to the Win client machine. Now, the first thing that you want to do in the event that the user figures it out or just kind of naturally closes that process, you want to migrate to a more common process that will likely be running as the system is up. And one of those processes is explorer.exe. So we want to attempt to migrate to that process. So we do migrate-n explorer.exe. Okay, so you see it's migrating from 4344 to 528. So these are process IDs. And in fact, if we come over to the to the Win client, and there is a tool called Netstats, and it will take a look at open TCP connections, established connections, and we can also look at potential process IDs that are related to that. So if we use this, the options -A and O, we get this back, and if we look, we actually see an established connection here, and this makes sense. It's on port 5000. We're connected to the Kali machine, which is the foreign address, and we see a process ID, PID, of 4344. So that makes sense. This would kind of be a first step in incident response. If you think you have malware on your system, I think a lot of people, they tend to like, oh, let me open Task Manager and see what's running. But this is actually a really good way to have a look, see if there's any established connections that seem odd, and that are potentially beaconing out to an address. And in this case, you could even, this obviously is an internal IP because this is all a sandbox lab. But if it was an external IP, you could do more research on that IP, see if it's like on any blacklist databases, things like that. See if it's a known malicious IP. All right, so let me come back to Kali. Okay, so this has happened, or sometimes common in Metasploit. Sometimes exploits and migrations in this case don't always work the first time. So it's not a perfect science, but so let's go ahead and I'm going to exit out of here. I'm going to go ahead and run this again. So we're waiting again for another session. And I'm going to go ahead and redo this. Okay, session 2 is opened. I'm going to press up again. Let's go ahead and try and migrate that again. And now we see we have a different process ID. And to explore.exe, that is the same because that process has stayed the same. Okay, so if this happens to you, notice up here, we got an error running command migrate. I just exited from the current session, ran the handler again, and then migrated again, and then we were successful. So from my experience running Metasploit, running multiple, if you're running exploits, no matter what it is, sometimes you just have to do it maybe once or twice extra to get it going. But now that we got that migrate successfully, we're still connected. Let's run some commands within Meterpreter. So remember, this is a kind of an expanded shell. It gives us more options. So get UID, server username. We are on the CySA student. That is referring to the Win client. We're logged in as the student account. Let's go ahead and take a screenshot. Okay, screenshot save to. We can open up the files folder here. It's in the backdoors folder. Double click this here. There you go. We're able to get a current screenshot of that machine. Okay, the lab was kind of detailing how you can open it in Firefox through the command line. I just went to the files folder and located it there. It's up to you if you'd like to do it this way as well. Let's look at key logging. So from Meterpreter, key scan _start, starting the keystroke sniffer. So now if we come back to Win client, let's go ahead and open up Notepad. And let's go ahead and type this in. When key logged, a user will usually have no idea that their keystrokes are being recorded. Okay, we'll go ahead and save this. We'll save it to the documents folder. And let's go ahead and call that labdownload.txt. Okay, I'm going to close Notepad. Now back in the Kali machine, let's go ahead and dump any keystrokes that have been caught here. Keyscan _dump. Interesting. It only captured Notepad. So remember, that was when I typed in here and typed in Notepad, but for some reason it actually didn't capture within Notepad itself. Not quite sure why that is, but we'll continue. Okay, and the lab is pointing out, obviously these labs aren't set up with webcams, but you can see how easy it is to record mic, turn on the webcam stream, take snapshots from the webcam. So this is all the scary stuff that you hear about. Also a good reason why you should really only have your webcam honestly connected when needed. Or if it's built in, you may want to deactivate it also when not in use, or there are those covers that you could purchase for webcams as well. Okay, now we could very easily exfiltrate data from this machine. So let's go ahead and download that text file that we had just created on the Win client machine. So download C:// remember for Windows, users, student, documents, lab download.txt. Okay, that downloaded. And let's upload the screenshot that we took. So I'm gonna open up the files browser here, go to backdoors. Let me size this so we could read. So this is the screenshot file name here. Here you can see the lab download.txt. If I double click that, here is the notepad file that we created on the Win client. Very easy to just grab that. But here we want to upload from root backdoors, and then the file name is, yours will likely be different than this, so make sure you pull your screenshot file name .jpg. And now we need to tell interpreter where to place that file. So C:// users student documents. Okay, so that is uploaded. This is another way to upload even more malicious applications or scripts. So if we come back to Win client, and if we look at documents, here is that screenshot. Okay, yep, found that. We could also do standard Linux commands like using cat command to just output the contents of a file just straight into the interpreter shell. So cat C drive users student documents lab download.txt. So there you go. There's the text file that we created. And we could also do a hash dump. So we can potentially pull hashes from this machine. So run, and this is essentially running a post exploitation module within Metasploit. So we're not interfacing directly with it, we're just telling it to run straight away within this current interpreter shell. Oh, I'm sorry. You should not have the / in the front there. So it's just run post / Windows. There we go. Okay, so we retrieved hboot key. We got an access denied here, likely because we are just logged in as the student account and not as administrator. So we have kind of limited access there. Now, moving on through the lab, on the Win client machine, we can use PowerShell to kind of study these processes, go a little bit deeper than what I had showed you previously with Netstats. So if we search down here for PowerShell, we're going to want to right click, run as administrator. Okay. So remember before we ran netstats -ano. And in fact, I feel like this part is kind of missing in the lab, because the first thing they do is go straight to these PowerShell commandlets that kind of assumes that you know the IP address already. But I would say the this netstat command is a good way to find these potentially malicious connections, as we see right here, and then do further analysis on that. So now this is how we could say, okay, I want to look more into this 192.168.1.3 IP. I'm going to go and clear the screen. And in fact, let me resize the font a little bit. There we go. So now this command here is going to give us a little bit cleaner details about what's happening. So get-net TCP connection. So this is basically think of this as almost an advanced and a little bit more refined netstat. And we're specifically giving it one address that we want to look at. Okay, here we go. So this is our local address. This is the IP of the Win client. This is the remote address that we're connected to, which is the Kali machine. Remember, we're on port 5000. This is a currently established connection, which makes sense. We currently have this Meterpreter shell open. We are connected. And then the owning process here is 2404. So that's the process ID of putty.exe, which was what we ran, right? So there's a command in Windows called kill that we could just very simply kill a specific process by PID or process ID number. So we know that it's 2404. So what happens if we type kill 2404? Well, we get this error. And you're likely scratching your head thinking, well, I know that this process is here. Why can't I kill it? Well, this is because the process was migrated. So remember that step in the Meterpreter, the very first thing we did when we established that connection, we migrated to explorer.exe. Now, we can take a larger list of all the running processes by using the command ps. And if I scroll up, you can see that we have Explorer here. And so now we know that the process ID is 528. And remember, when we migrated that, I don't know if I could scroll up that far. Yeah, I can actually. When we migrated, it shows us here it migrated to 528, which was for explorer.exe. So we can go ahead and kill that process ID. And also note, as you look through this lab, the screenshots, these are not going to be the same process IDs. It's always going to be different. So just be mindful that you are running these commands on the process IDs that you are working with currently. Okay, so kill 528. Are you sure you want to perform stop process? So this is essentially running the stop process command or operation on Explorer. We're going to say yes. And now if I come back to Kali, you can see the Meterpreter session 2 has closed. So because the original process was killed. So that is one way to kind of close that connection. Now let's go ahead and run another handler. I'm going to go ahead and exit, do run. Okay, we have another handler listening. And let's go ahead and rerun. Go to File Explorer, C drive, FTP. I'm going to rerun the Trojan. Double click, come back to Kali, Okay, Meterpreter session 3 has opened now. Now let's see what happens if we don't do that migration. Let me go ahead and clear the screen. Let's go ahead and run netstat-ano again. If I scroll up, okay, we have that connection here established on process 364. 364. But let's go ahead and rerun this commandlet. So get net TCP connection, remote address, give it the IP of the Kali machine, format that. Okay, so similar information as the netstat, neatly formatted, right? Owning process is 364. So let's go ahead and get a little bit more information about that process ID. So this, we can say get process -ID 364. Remember, your ID is going to be different than mine or within the lab. And let's pipe that to format list and asterisk. All right, so we get a lot of information back. If I scroll up, you could see we have now found the exact path or source of this process. So we could say, this putty.exe is establishing this connection to this random IP address that I'm unfamiliar with. This seems suspicious. And now, because we haven't migrated this, we could run kill 364 on this process. Yes, I'm sure. Okay, this time we don't get any error. If I rerun, I'm going to press up a couple times, look for any connections with this IP. There are no connections found. And if we go back to Kali, we notice that the Meterpreter session has been closed. So yeah, so that's kind of an example on the offensive security side, the red team side, why it's important to migrate the process. Now, this lab kind of skims over how you figure out which process it migrates to. That's kind of like for a more deeper malware analysis type of lab. But just know that there are methods to kind of trace the steps that these process migrations take. And that's all a part of the whole malware analysis process. So, but with that, this concludes this lab. So once again, this was all about extracting data from a compromised machine. We created a remote access Trojan using a payload, using the msfvenom tool. We then, uploaded that to the Win client machine through FTP, launched it, and then looked at how you're able to interact and exfiltrate data from that machine once the malware or Trojan was run. So I hope you enjoyed, and I will see you in the next video.